Could water be the energy source of tomorrow? It can be used to produce the wonder known as green hydrogen, a fully climate-neutral gas. But it's still time-consuming and expensive. That's why billions are being spent on research, such as on this artificial sun. It has 149 lamps, each as powerful as a large cinema projector. The idea is to produce fuel using only light and water and release no greenhouse gases. It's already being used in solar plants just like these. Will green hydrogen save the climate, or is it just an environmental fad, as volatile as the gas itself? Eckernförde Naval Base, 8 a.m. This submarine also relies on hydrogen. The U-35 is ready to head out. 6 torpedo tubes, 4,200 horsepower, maximum diving depth, deep, so deep, it's a secret.
It's great that we can finally put out to sea.
A crew of 29 women and men. Final orders have been given and the crew goes aboard. Their home for the next few weeks is just 56 meters long and 7 meters wide. A tugboat pulls the U-35 away from the pier out to sea, where first a diesel engine is fired up. But when the boat goes underwater, a hydrogen fuel cell with a battery and electric motor kicks in. This technology was first used in Germany in 2005.
The advantages are one. As we're moving, the craft is silent. We make very little noise. In addition, we emit an extremely low level of heat, and that makes us almost completely undetectable underwater.
Ultra-quiet voyages with hydrogen. Secret, submerged missions of up to 2 weeks are now possible. Quieter, cooler, and all without harmful exhaust gases.
We mainly have water which is left over from the electrochemical reaction, and we can use that as grey water if need be.
The Navy now has 6 hydrogen-powered submarines. They were developed more for tactical advantages than climate protection. But the German submarines prove hydrogen technology has potential and works. But can it succeed elsewhere? Ralf Oeswein from Großzimmern in Hesse loves technology. He collects Unimogs, historic military vehicles. Although they still run on diesel, his SUV runs on hydrogen. Both fascinate him. For Oeswein, both represent progress.
It's simple. The time has come. We are entering a different era. We grew up with this old technology. It got us this far and brought us the prosperity we have today. And now we have to take this old technology and develop new technology.
Everything looks neat and tidy under the hood. Oeswein's car and the submarine have essentially the same technology, and it works like this. Oxygen from outside air and hydrogen from the tank flow into the fuel cell, where a chemical reaction occurs. This produces electricity for the motor that powers the car. Only pure, clean water vapor comes out of the exhaust. Even the air is filtered in the process. It almost can't get any cleaner than this, at least while it's moving. The hydrogen in the tank is not yet climate neutral. Up until now, it's been made almost exclusively from natural gas, which emits carbon dioxide during production. And Oeswein had to dig deep into his wallet for this car. Starting price, nearly 80,000 euros. As a luxury car, it's still just a niche. At the moment, only Hyundai and Toyota offer hydrogen vehicles, and around 300 were registered for the first time in 2020. This makes Ralf Oeswein a bit of a trailblazer, so far at least. Hydrogen is already used far more often than you might think. More and more cities are converting their bus fleets. Fuel cells help the large vehicles last longer during the day than with just batteries. And the first hydrogen trains have been rolling through Lower Saxony since 2018, replacing diesel locomotives in places where there are no overhead lines. And this is what the future could look like for trucks. A prototype from Daimler Trucks, futuristic, but not at all science fiction. It could go into production as early as the mid-2020s, with a range of up to 1,000 kilometers. A current impossibility with just an electric motor and battery. Hydrogen is also taking to the skies. This may look like just any other plane, but it too is powered by a fuel cell. Manufacturer Zero Avia developed the plane in just 3 years and tested it last fall in Cranfield, England. Hydrogen has arrived in aviation, in small aircraft for now, but the manufacturer is already thinking bigger.
The objective of this program was to figure out and design all the components that would go into the larger powertrain. That is really our commercial target, about 600 kilowatts in power, replacement for turbine engines of similar size that go into 10 to 20 seat aircraft.
More power, more range. A solution for longer travel too. According to a concept from Airbus, yes. Hydrogen-powered jets could take off as early as 2035. But they would only be climate neutral if they used exclusively green hydrogen. These kinds of futuristic visions are not new. 150 years ago, author Jules Verne predicted that water would be the energy of tomorrow. The concept of green hydrogen existed even back then. But first came the era of crude oil, its cheap price giving it a clear advantage. Hydrogen was instead used to elevate the Zeppelin, but in 1937 it became clear that hydrogen was not to be taken lightly. Leaks and a discharge likely triggered the catastrophe. To this day, hydrogen's image remains tarnished. Yet the element is present almost everywhere, never in its pure form here on Earth, but rather as a building block, for example in water. A renewable and inexhaustible source. The problem? A lot of energy is needed to use it. Katharina Reiche is just one of the researchers dedicated to solving the problem. She is head of E.ON subsidiary Westenergie and also chairwoman of the National Hydrogen Council, a body of experts advising the German government on just how to implement its hydrogen strategy. Its goal? Using green hydrogen as one of the solutions to make Germany climate neutral by 2050, with federal backing of 9 billion euros.
Green hydrogen is not yet produced in large quantities. It's simply too expensive to produce without large economies of scale. So to overcome this, what we need is both a robust market to sell hydrogen and the ability to produce it in large enough quantities for such a market. To build up a reliable and coordinated supply chain, to gather its production, transportation, and account for all of its potential uses, that's the major challenge.
One main problem: green hydrogen only comes from green energy, and there is not enough in Germany yet. In order to meet estimated demand for hydrogen, 5 times the current volume would be required.
That's the ultimate goal, and to get there we need to continue to have the political willpower here in Germany to expand our green energy network. Unfortunately, that process has lost a lot of steam over the last few years. But we think that with this new push that's possible via hydrogen, the topic of renewable energy will finally regain momentum, and as a result, the costs can come down.
These wind turbines already provide green energy to 40,000 households in Baden-Württemberg. Some of it also flows here to the German Aerospace Center in Lampolzhausen, where rocket engines are tested. More precisely, to this research facility H2O Ryzen. Only green hydrogen is produced here. Daniela Lindner and her team are at home here. They just completed a test. The electrolysis plant uses electricity to split water into oxygen and hydrogen. Every year, up to 100 tons of green hydrogen are produced here without any greenhouse gases. This time, however, with an hours-long delay because the wind only picked up in the afternoon.
When the wind stops blowing, it's a real problem that we can't produce anything. But with a combination of different renewable energy sources, for example, like solar, it's still possible and practical to continually produce hydrogen.
Möglichst kontinuierlich eben den Wasserstoff produzieren zu können.
Especially with large quantities. The principle of green hydrogen has been known for a long time, but it is not yet efficient enough. Lampolzhausen won't be the only one that will need a lot of green hydrogen.
The green hydrogen produced here on site is transported to a central supply facility via pipeline, and then from there it can deliver green hydrogen to specific individual campaigns at rocket testing sites.
Campaigns are what they call the rocket thruster tests. Right now, they're testing those aboard Europe's newest rocket, the Ariane 6. Its first launch is scheduled for 2022, using a fuel mix that includes liquid hydrogen. This technology has been proven in space travel. As early as the 1960s, spacecraft used it to fly to the moon. Ariane 5 also has hydrogen in its tank, albeit not the green variety. Daniela Lindner and a colleague are making plans to change that. Until now, liquid hydrogen produced from natural gas has been delivered and stored in special storage tanks at -253 degrees. It becomes gaseous at higher temperatures. A new plant will soon be built to liquefy green hydrogen gas on site. Pipelines will then distribute it around the site to the test stands for rockets and also to 2 combined heat and power plants and a filling station. When everything is connected like this, energy experts call it sector coupling. And it has a lot of advantages. Energy from wind and solar plants would flow into the power grid as it does now. If there is plenty of sun and wind, hydrogen could also be produced. The hydrogen could then be converted back into electricity whenever there is a lull in wind power and reserves are needed. But it could also have other applications, heating, for example, or in the glass, cement and steel industries, or in the transportation sector. The more interconnected the distribution, the more economical it becomes. A completely new technology for hydrogen production is at work here in Jülich. The world's largest artificial sun stands in a 14-meter-high room. With its 149 lamps, it produces 10,000 times the amount of sunlight that reaches the Earth, at temperatures of up to 3,000 degrees. But why have an artificial sun when there's a real one?
The artificial sun helps us move faster than if we were to rely on the real sun. You know, the sun rises in the morning, then the clouds pass through, and in the evening the sun sets again. We would normally have to rely on whenever the sun is shining, but here we can turn on the sun when we need it.
The goal of Christian Sattler and his colleague Dmitry Labar, splitting water into oxygen and hydrogen using only the heat from light, instead of using electricity as in electrolysis. The advantage:
I have the sunlight here, which I direct with mirrors onto the reactor. Then that sunlight sparks a reaction. If I first have to convert it into electricity and then convert the electricity into chemical energy, I have 2 more conversion steps. Each step means some loss, even if the equipment is very good.
Researchers have already proven that the process works in the lab. Hydrogen production using only sunlight and no electricity. A completely climate-neutral technology. But can we use it to produce hydrogen on a large scale? Many details still remain unclear. A new test is currently being prepared. Safety is the top priority.
Standing here when this thing is fired up is a bad idea. These lamps are extremely powerful.
Burns and blindness would be the result. This hole, melted through a 5-centimeter iron plate, proves just how powerful the concentrated light is. That's why the lamps are only turned on when no one is in the room. A thick metal wall provides additional protection. Only then can the researchers begin the experiment. As an expert in occupational safety, Ralf Oeswein travels a lot for his job. He has to refuel at one of only about 90 hydrogen fueling stations in Germany. That requires planning with the help of an app. But the refueling itself is no more complicated than with other cars.
The whole process takes about 3 to 5 minutes. Then the vehicle is fully refueled. On a tank of gas, you can go about 580 kilometers. I was able to drive on 6 kilos of hydrogen gas.
A full tank costs between 50 and 55 euros. Oeswein also tried electric cars, but they aren't yet a viable alternative for him.
I travel all over Germany and would like to avoid the long refueling stops, those charging stops with an electric vehicle. A hydrogen vehicle is a good option for me because I drive a lot. I use it every day.
Green hydrogen at a petrol station is still rare. The reason? It still costs 3 times as much to produce as hydrogen from natural gas. According to Christiane Averbeck of the Climate Alliance Germany, green hydrogen for passenger cars is a mistake.
Hydrogen is still a rare commodity and should only be used in places where it really cannot be replaced by other options, such as electricity. So that means we should still rely on electric vehicles in the passenger car sector, while for heavy-duty transport in the aviation sector and also in large transport ships, we should use hydrogen.
In the end, hydrogen cars lose a lot of energy for manufacturing, transportation, and so on. Currently, only 27% of the original energy is left. That's still better than with gasoline cars with only 20%. But significantly worse than an electric car with efficiency of 64%. The DLR Institute of Vehicle Concepts knows the drawbacks, but they still see potential in hydrogen cars. The Safe Light Regional Vehicle is a prototype of a light yet safe city car. It has 2 electric motors, a battery, and a hydrogen fuel cell, all in a space and weight-saving design.
Der Vorteil, wenn wir so ein Brennstoffzellen-Hybridsystem bei so einem Leichtfahrzeug anwenden.
The advantage of applying this type of hybrid fuel cell system in such a light vehicle is that we have a very light powertrain, from the small battery to the tank and the fuel cell system.
Im Vergleich zu bei dem
That is, compared to a battery-operated electric vehicle, which needs a very large battery to deliver a 400-kilometer range.
Reichweite auch nachher liefern kann.
The concept's low price makes it attractive. The developers estimate that the city car could cost just 15,000 euros. The institute is already being bombarded by companies and potential customers. This keeps the scientists motivated.
Unsere Meinung am Institut für Fahrzeugkonzepte.
At the Institute of Vehicle Concepts, we think that there will continue to be a mix of different technologies in the future, and also different drivetrain technologies. There will also be vehicles that have to have a long range. And I will also have to look at which powertrain or combination of powertrains will allow me not only to travel efficiently, but also in a way that is green and conserves resources.
Und ressourcenschonend unterwegs.
Green and resource conservation. The steel industry wants similar results. Almost 40 million tons of crude steel are produced in Germany every year. This requires an enormous amount of energy and has a similar impact on the climate. Steel production is responsible for 1/3 of all industrial carbon dioxide emissions in Germany. It is far from climate neutral. That needs to change. At ThyssenKrupp Steel, hydrogen is being injected into the blast furnaces on a trial basis, instead of just coke and coal dust.
The trial we launched here in 2019 is the first step in converting steel production to hydrogen. We wanted to try it out in a large unit like the blast furnace you see behind us, and to see how hydrogen behaves when we use it to process ore into crude iron.
The results are so promising that the trial is now being expanded. However, CO2 emissions can only be reduced. This is because the technology in the blast furnaces has not yet been adjusted to gas. Therefore, they must be completely replaced.
That means we will soon build plants here that will be started with natural gas. But as the availability of hydrogen increases, the proportion of hydrogen will continue to increase until, in the end, we run them almost exclusively on hydrogen.
In the end, means that only green energy is to be used by 2050. ThyssenKrupp Steel alone could improve Germany's carbon footprint by about 2.5%. But they also think politicians have to play a role.
Steel production is not an end in itself. We have to remain economically viable. And when you realize that we'll need more than 10 billion euros of investment by 2050, then it becomes crystal clear that none of this will be possible from a global perspective without political support.
Global agreements have to address more than just subsidies. Quotas and rules for international competition are also important. But this political framework doesn't yet exist. Infrastructure for hydrogen also isn't yet available. Pipelines, for example, to bring the fuel to those who need it. This plant in Dorsten in North Rhine-Westphalia is part of Germany's natural gas network, which is more than 500,000 kilometers long. Pressure is reduced here from the long-distance network so that the gas can be delivered to homes and businesses. A hydrogen network would need similar equipment, but it hasn't yet been built. Unless the existing natural gas grid is gradually converted to a hydrogen grid.
It's definitely more cost-effective to use hundreds of kilometers of existing pipeline than to build a completely new hydrogen network.
That's why German power provider Westenergie is currently conducting initial trials, routing hydrogen through sections of existing natural gas pipelines.
We're testing out what the natural gas pipeline and all the other components, such as its seals and compressors, can handle. We're also looking into how much it would cost to convert the natural gas network in the long term. After the first tests, we're optimistic that the pipelines are completely suitable to carry 100% hydrogen.
There are still many unanswered questions. For example, who will operate the grid? And how can we make a smooth and gradual transition? In Jülich, things with the artificial sun are heating up. The 149 lamps are turned on from the safety of a control room. Special cameras film the experiment because it's too dangerous inside. The focused light splits the raw material in the reactor. Tests like this prove hydrogen can also be produced in larger quantities.
What we are primarily monitoring here is the size of the plant and how we can automate the entire process. We can then take that and show it to the industry. This is what a process looks like that you can actually use at your industrial scale.
Solar thermal systems would then take over the artificial sun's role. In them, sunlight is captured by mirrors and cast onto solar towers. Such plants, which would then be much larger, could play a key role in the production of green hydrogen. However, Germany doesn't have enough sun to make this work. More than half of the green hydrogen will probably have to be imported from Southern Europe, Africa, or Australia.
The idea is that such plants would be located in very sunny regions, in deserts. That land isn't used for anything else anyway. And there is a lot of solar radiation there, which means you can collect plenty of energy throughout the entire year. You can produce fuels like hydrogen much more efficiently and cheaply there with these kinds of plants.
So is the hydrogen revolution feasible? Will it move us closer to a carbon-neutral world?
For me, hydrogen is the industrial policy answer to the energy transformation. To put it another way, not champagne, but sparkling water.
Which means in the future, hydrogen will no longer be a luxury, but a fuel for all, as Jules Verne predicted. The path is already being cleared in business, research and politics.
I think that Germany's hydrogen strategy is an important part of a greater foundation that will further hydrogen's development. Nonetheless, I think it's important that we get our priorities straight and don't spend too frivolously. We need to put public funds in the right places.
Ralf Oestwein is on his way to a meeting at a construction site. He too believes in the future of hydrogen and in a mix of different climate-friendly technologies. Diesel and gasoline engines, on the other hand, are a relic of the past. Only a bit of sentimentality remains.
I don't miss the combustion engine. I miss the sound of a combustion engine, the gritty ticking of an old diesel engine, or the beautiful growl of a combustion engine. That's missing here. But I think technology will provide a solution. I can put in a CD or whatever and then have the right sound if I really want it.
That problem is easily solved. Others, though, on the road to a green hydrogen future, will likely take a while longer.